Alright, so now we're just going to dive into the actual calculations for matrices. First thing we're going to do is we're going to talk about adding and subtracting matrices. Okay, so if you're going to add / subtract matrices, the main idea here with adding and subtracting is you're just going to combine the corresponding entries. I think I spelled that wrong. Is there an E in there? I think so. Anyway, combine corresponding entries. Okay. All that means is that when you add two matrices together, you add the first entries together, then you add the second entries together, and so forth. Okay, one of the conditions then that follows from this is that the matrices must have the same size. If they don't have the same size, then there's going to be some entries in one that don't have a corresponding entry in the other. So, must be same size. Okay, it must be the same size. So let's just say I wanted to add two matrices. Let's make them 2 by 3s. So there's a 2 by 3, and let's say I wanted to add another 2 by 3 to it. Alright, so there I've got two 2 by 3 matrices. When I add them, again, we're just going to combine the corresponding entries. So the first two entries, first row, first column in each, we're going to combine those. 2 minus 3, or 2 plus negative 3 is negative 1. 4 plus 6 is 10. Negative 1 plus 2 is 1. Negative 3 plus 8 is 5. 2 plus negative 4 is negative 2. 5 plus 7 is 12. Alright, so there's our sum. So literally we must take the same size matrices and combine their corresponding entries. Okay. If the matrices are not the same size, then they cannot be added. There's no answer there, no solution. Okay. Same with subtraction. You would just combine the same entries. Let's take let's go with 1 by 4 or something here. Let's go negative 1, 3, 2, 5, and let's subtract negative 4, negative 8, 2, 6. Okay, so on this one, we're just again going to combine corresponding entries. So negative 1 minus negative 4. Well, double negative there makes for a plus, right? So negative 1 plus 4 is 3. And then 3 minus negative 8, again a double negative. 3 plus 8 would be 11. 2 minus 2 is 0. And 5 minus 6 is negative 1. Okay, so again, you're just combining the corresponding entries. Okay, now the next operation we're going to talk about is called scalar multiplication. And in scalar multiplication, you're just multiplying a matrix by a number. That's what scalar means, a number. Okay, so you're multiplying by a number, and then that number is going to multiply by to every entry. So, multiply a matrix. It's supposed to be two words there, and a number, and you multiply to every entry. Okay, so an example might be 5 times the matrix 2, 3, 0, negative 4. Alright, well, the scalar times the matrix, again, you multiply to every entry, so 5 times 2 would be 10, 5 times 3 would be 15, 5 times 0 is still 0, and 5 times negative 4 is negative 20. Okay, so it almost looks like the distributive property, it just multiplies to everything. Okay, make sure you can see that. So everything gets multiplied by the 5. Alright, and so these really aren't that complicated, but we could also do some combinations of more than one of these operations. You could do something like the matrix 2, negative 3, negative 1, and 4, minus 3 times the matrix 1, 1, 4, 2. Okay, and in this example we just combine, we'd have to distribute here, and so you'd have 2, negative 3, negative 1, 4. And now you could either distribute the negative 3 and change this to a plus, or keep it a minus and just distribute the 3. That's what I'm going to go ahead and do here. So 3 times 1 is 3, 3 times 1 is 3, 3 times 4 is 12, 3 times 2 is 6. And then do the subtraction. So 2 minus 3 is negative 1. Negative 3 minus 3 is negative 6. Negative 1 minus 12 is negative 13, and 4 minus 6 is negative 2. Okay, so that should give us 3 new operations: adding, subtracting, and scalar multiplication.